You might be surprised to see a whole section about these inverse trig functions since we've already been using them, but actually it turns out there's a lot of technical details involved in these functions that we have to take a look at about how exactly they're defined. So first, just to remind you of the basics here, we have the regular trigonometric functions where you input the angle and it outputs the ratio, and so we use these inverse functions if we wanted to input the ratio and output the angle. So we use these to find angles. The thing is, though, if we're finding angles, there's always an infinite number of angles that have any particular trigonometric value. So if we think about sine of theta being a half, so we think on the unit circle, the y-coordinate being a half, and that's our pi over 6. But of course, that's not the only angle that has that y-coordinate on the unit circle. We know we can think about ASTC, and the sine is positive in 2 different quadrants. And so in addition to pi over 6 in the first quadrant, we could also have a second quadrant angle with pi over 6 as its reference angle. If you're very familiar with your unit circle, you'll know right away that that's 5 pi over 6. If you have to think about that a little bit, that's fine. Again, you can either count around 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. All those other ones reduce until you get to 5 pi over 6. You can also think about starting at pi and then subtracting pi over 6, 6 pi over 6 minus 1 pi over 6 gives you 5 pi over 6. But there's another possible angle, but then there's a whole lot more. Because again, we have those coterminal angles where you can go in a full circle, land in the same place, just with a different rotation. So we could add 2 pi to these angles. Adding 2 pi would be adding 12 pi over 6. So we could have 13 pi over 6. We could have 17 pi over 6. We could also subtract 2 pi. We could subtract 12 pi over 6. We could have negative 11 pi over 6, and so on. There's an infinite number of angles. We could keep adding and subtracting 2 pi. So out of all those infinite number of angles that have a sine of a half, the inverse sine of a half has to just pick one of those values. Inverse sine is a function, and a function is only allowed to have one output for each input. Well, out of this whole list, it's probably pretty obvious which one we would pick. We would just pick pi over 6. The inverse sine of a half, we're going to pick the pi over 6. And so even though there's an infinite number of angles that solve this equation, inverse sine of a half is always only pi over 6. That's the only possible angle for the inverse function. It's kind of like if we solve x squared equals 9, we have 2 solutions, a quadratic, a degree of 2. As the 2 solutions there, we have plus 4 minus 3. 3 squared is 9, negative 3 squared is 9. But then if we look at the square root of 9, the square root of 9 is just 3, because square root is a function. And you can also think about, these are things that you want to be able to type in your calculator, and your calculator is just going to give you one answer. If you take a look here, if I type square root of 9, in my calculator, it's just going to give me the 3. It's not going to give me the negative 3. Same thing if I do arc sine, I'll do inverse sine in my calculator in radians here. Inverse sine of a half going to give me this decimal. That's the same thing as pi over 6. We have to have just one answer in our calculator, one output for the function. So out of these different values that solve the equations, we have to just restrict it, pick it to one possible answer. This can be the output for the function. So for square roots, we always picked the positive value. Here is probably pretty obvious why we would just pick pi over 6. So what we need to do is we need to kind of look at what are the rules for how we pick which angle we use. Out of all the solutions for the equation, how do we pick the angle that's the answer for the inverse function? Sometimes it's a little more obvious, sometimes it might be a little bit tricky. So let's look at some examples here. So if we want cosine to be negative a half, on the unit circle, the angle with an x coordinate of a half, now we want pi over 3. So if we just wanted a cosine of positive a half, we'd say pi over 3. For negative a half, again, look at ASTC over and over and over again in this class. Cosine being negative, we've got either the second or the third quadrants. Again, if you need to think about that for a little bit, what the pi over 3 reference angles are in the second and third quadrants, you can, but that's going to be 2 pi over 3 and 4 pi over 3. And of course, there's an infinite number of solutions. You could add 2 pi, and that'd be adding 6 pi over 3. You could have 8 pi over 3. You could subtract. You could have negative 2 pi over 3, and so on and so on and so on. All these angles satisfy that equation. But out of all of these, which one would we pick? Again, we're gonna pick kind of the first one, the smallest positive angle here. This 2 pi over 3 is going to be the one we pick. So far, it's probably seeming pretty straightforward about which angle we pick. But let's go to sine here. So if we want sine to be negative a half, we've already seen the reference angle has to be pi over 6 for sine to be a half. But now if we want sine to be negative, we're looking in the third and the fourth quadrants. And that's going to be 7 pi over 6 or 11 pi over 6. But actually, neither of these is the value that we use for arc sine. So by the way, this is just another notation here. You can either say inverse sine or you can say arc sine. Same thing for all these. It doesn't matter whether you use a little -1 or an arc. Inverse sine or arc sine, inverse cosine, arc cosine, they mean exactly the same thing. And so, well, right here, what angle are we going to use then? If we don't use one of these two angles, what else could we use? There's actually what we think of as a simpler angle, an angle closer to 0 that will work here. We can actually use negative pi over 6. If you subtract 2 pi from 11 pi over 6, you get negative pi over 6. Again, 2 pi is 12 pi over 6. And so if we take 11 pi over 6 minus 12 pi over 6, that'll give us negative pi over 6. So negative pi over 6 is a coterminal angle. Another angle in the same spot. It also has a sine of negative a half. And this angle has less rotation involved. It's an angle closer to 0. And so this is the one that we would actually use for negative pi over 6. All right, so let's try to put all this together into maybe some more formal definitions. A good way to look at this is to think of the graphs. So you might remember when we covered inverse functions, for something to have an inverse function, it actually had to pass the horizontal line test. Well, none of these functions pass the horizontal line test. Every single one of them, you can draw a horizontal line that crosses multiple points. But we still want something of an inverse function, something that helps us go backwards, kind of undo these functions, switch the input and output. So what we had to do is just take part of the function. So for x squared, what we did is we chopped off the left half, and the square root graph is the inverse of only the right side. So if you look at just the right side of x squared and you look at square root of x, those are inverses of each other. So square roots are always positive. They're the positive part of that graph. So we need to make a similar choice for these graphs. We need to kind of chop these graphs into just a smaller piece that would have an inverse function. And the thing is, we need to be able to cover both positive and negative values. And so for sine, to cover both positive and negative values, the piece that we choose is right here. If I chop off the rest of the graph right there and just choose that piece, I'll cover both positive and negative sine values. If I just look at that piece, it will pass the horizontal line test now. It will have an inverse function. And so we're going to be looking, this is from negative pi over 2 to pi over 2 right here. We're going to use angles that are in quadrant 1. And then these angles right here are our negative quadrant 4 angles. We'll try to put this together into kind of some simpler rules in just a minute and do some examples, but just to show you where these definitions come from. You can do a similar choice for tangent. You can choose the part of the graph that's centered around the y-axis here, and that gives you negative values and positive values. You've got quadrant 1 over here, and you've got your negative quadrant 4 angles over there. It gives you both positive tangents and negative tangents. Cosine is going to be the one that's different. If you made the same choice for cosine, you would only have positive cosine values, and you would still fail the horizontal line test. So for cosine, we're going to choose this piece of the graph right there. We've got quadrant 1 for positive cosine values, and down here we've got quadrant 2 for negative cosine values. If this part didn't make too much sense to you, don't worry too much about it. This is just trying to show you where some of these definitions come from. At the end of the day, mathematicians made these choices for you. You can just kind of go with their definitions, go with these rules, and don't worry too much about that. So kind of a rule of thumb is you can think about, as I was mentioning before, an angle that's closest to 0, an angle with the least amount of rotation. And so what that means is anytime you want these inverse values for a positive value, you just do kind of the first angle you think of, the quadrant 1 angle. You don't think about it too much. So again, arc cosine is the same thing as inverse cosine. It's just another way of writing the same thing. And so if we think on the unit circle, that root 2 over 2, or you might know it as 1 over root 2, that's your pi over 4 angles. And you just say the pi over 4. It's also true that 7 pi over 4 has that cosine. It's also true that negative pi over 4 has that cosine. There's lots of other angles that have that cosine. But the arc cosine, the inverse cosine, is just going to be that angle. If you punch this in your calculator, that's going to be what your calculator says. Same thing for these other values. Just give the first angle that you think of. You want sine to be root 3 over 2 on the unit circle, a y coordinate of root 3 over 2. That's pi over 3. Tangent might be the one that you have to think about a little bit more. Remember, tangent is the y over x. So if you want y over x to equal 1, that means y and x have to be the same thing. So that's going to be pi over 4. Again, these we don't have to think about too much. When it's positive, you just give that first quadrant 1 angle. You don't worry about it too much at all. Okay? It's the negative ones that get a little bit tricky. Okay? Sine and tangent aren't too bad, though. When you do inverse sine and inverse tangent, you're just going to do a negative angle. So whatever it was without the negative, whether pi over 3, pi over 6, pi over 4, just stick a negative on those angles. So right here, inverse sine of negative root 3 over 2, now that's just negative pi over 3. Right. Again, it's true that 4 pi over 3 has that sine value, but that's not the angle that we use. It's also true that 5 pi over 3 has a sine of negative root 3 over 2, but that's not the angle that is the definition for this inverse sine function. We need an angle. The formal definition here is that inverse sine, the output, has to be between negative pi over 2 and pi over 2. Same thing for this arctan of negative 1. We just say negative pi over 4. Just stick a negative on the angle. When it's inverse sine and inverse tangent for a negative, just stick a negative on it. Inverse sine, inverse tangent really is. We just stick a negative on the angle. Okay? Cosine is the one that's different. Because if I said negative pi over 4, that would be in the 4th quadrant. And then the cosine would be positive. So I can't say negative pi over 4 here. What we do for inverse cosine is we look in quadrant 2. And that'll be the angle that's closest to 0, the smallest angle that has that negative cosine. Again, if you're trying to decide an angle for an inverse function, just choose the one that's closest to 0. That'll usually get you there. Again, I'm looking for a pi over 4 reference angle. And so if I want this to be in quadrant 2, that's the rule for cosine. Pi over 4 reference angle in quadrant 2, that's going to be 3 pi over 4. Okay? So when you're finding these values, the first part is always that unit circle memorization piece to find the reference angle. And then when it's negative, just use these rules. Either stick a negative on it for sine and tangent, or look in quadrant 2 if it's cosine. And formally, you have to consider these intervals here, but these rules will usually get you there. Right? The one that can give people a little bit of trouble sometimes is this arc sine of negative 1. So just remember, you want sine of theta to be negative 1. You're looking for an angle whose sine is negative 1. And so on the unit circle, we would need the y coordinate to be negative 1. We need an angle that's straight down. You're used to calling the angle that's straight down 3 pi over 2. but that doesn't fit this rule here. Sometimes people will stick the negative on that, but call it negative 3 pi over 2. Negative 3 pi over 2 would be straight up. That's no good. So the angle that you want here, you want it straight down, but it has to be a negative angle. Straight down, that's a negative angle. That's negative pi over 2. Then we have some of these where we put the regular trig function and the inverse trig function together. For those, you just work your way inside out. So start by just doing inverse cosine of 0. Just make sure you keep straight whether you're looking at an angle or whether you're looking at the ratio, the value on the unit circle. So inverse cosine of 0, that says find an angle. Inverse trig functions are angles. Find an angle whose cosine is 0. So we're not talking about the angle 0. We want the cosine to equal 0. And so if we look on the unit circle, there's two possible places where cosine could be 0. The x-coordinate could be 0. Again, rule of thumb, choose the smallest angle, the angle closest to 0, kind of the first one you can think of usually. And so that'll be pi over 2. So that's this inside part here. And then we just need to find cosine of pi over 2. And of course, cosine of pi over 2 is 0. And so notice these just kind of canceled each other out here. You might have expected that. Remember from last semester, f of f inverse equaled x. Square root and squaring usually cancel each other out. Just be a little bit careful because that doesn't always happen. Because of these domain restrictions happening here, there's a little bit of funny business that happens. So if you look at this, tangent of 3 pi over 4, 3 pi over 4 is in the second quadrant, so its tangent is going to be negative. And we've already seen whenever the reference angle is pi over 4, tangent's going to be 1. So we've got negative 1 here. So then we want to do inverse tangent of negative 1. And while it's true that tangent of 3 pi over 4 is negative 1, that's not the angle that inverse tangent chooses. That's not the definition of inverse tangent for negative 1 there. Inverse tangent of a negative, we need a negative angle here. We already did this problem actually already. We just called it arctan instead of inverse tangent. It's the same thing. This one has to be negative pi over 4. And just because of this domain restriction, this funny business that we did back here to restrict the functions, sometimes these won't cancel out the way that you think they will. So just work them out carefully. Just start from the inside, do the inside part first, and just do one part at a time.